Hi, everyone. Welcome to Taking Control with Microgrids. I'm Bo Jones at Agilitech, and I'm going to be kind of hosting, emceeing, and presenting to you my team here. We've got some experts from Agilitech on with us. Ruben Garola, who is our lead project designer, and Andrew Lackey, our lead electrical designer at Agilitech. Some of the many talented people here. These two are especially proficient in the topic of microgrids, as they have experience in designing and engineering and deploying these types of systems. My background is pretty mixed. I've got some experience in operations in an operation for the ag industry before I joined the energy sector in 2020. And since that time, have been involved with quite a few renewable powered off-grid or microgrid type configurations for a number of different projects across the US as well as internationally. And so in my time at Agilitech, I've had the pleasure of working with a number of microgrid projects and many more to come. So we wanted to take the opportunity today to share a little bit of that work. So in terms of the topics, we're just going to kind of go through this list here. What is a microgrid? We'll talk a little bit about the landscape, the past, present, and future. We'll hear from Ruben on that. And we'll talk about the anatomy of microgrids, what really makes a system microgrid, what makes them work, some lessons that we've learned from actual projects, and then a little bit of takeaways to kind of close this out. So like Lulu said, we're super excited to have the opportunity to kind of co-share this with Sunstone, and hopefully you guys can learn from our experience, and if you have any questions at all, feel free to drop those in the chat along the way. So a little bit about Agilitech. We've been around since 2002. We're based out of Bakersfield, California, licensed in California, Arizona, and Texas. And our offerings are very broad. We have a pretty diverse suite of services that we perform to just about any commercial or industrial application you can think of. We've worked with a lot of large companies. We work with a lot of small companies too. Just depends on the needs. But yeah, by and large, the easiest way to explain what Agilitech does is all things power. That's how I like to kind of summarize it. We also have a custom fabrication shop for electrical panels for controls and distribution type products. So a little bit of everything and a lot of some things. So for the purpose of our conversation today, I wanted to identify what is a microgrid. And like Lulu called out, there's a pretty simple one question poll running that you're free to answer in any way that you want. We really just wanted to use that as a way to gauge everyone that's attending today to capture the idea that there is a lot of shapes and sizes that microgrids come in. And depending on the project, depending on the customer, depending on who you're talking to, they can take many shapes and forms. Some of those are renewably powered and some of them are not. But the basic premise behind what a microgrid is depends on who you're talking to in a lot of cases. So generally you're going to have a load of some kind. That's kind of the main requisite. But you're going to have all of these different components, and we're going to dive more into detail about what these things are. But hopefully we get enough into the details to kind of shed insights, but also we want to capture kind of the different variations of these things. So if you were to ask the Department of Energy, you're going to get this very official looking definition. A microgrid is a group of interconnected loads and distributed energy resources within a clearly defined electrical boundary, acts as a single controllable entity with respect to the grid, usually being the utilities. Microgrid can operate in either grid connected or island mode, including entirely off-grid applications. A super broad and comprehensive definition, but for us, most of us here, I think, are operating in the commercial and industrial space. Probably some folks are doing utility projects, some are doing residential, but the core of our application for microgrids at Agilitech is commercial and industrial, generally always behind the meter. So when I'm speaking with different stakeholders involved in a project, I try to be cognizant of who I'm speaking with and what their impression or understanding of this definition might be, because the way that we're talking about these things does matter depending on their involvement. So for me, the plain English explanation of what a microgrid is for most of our commercial or industrial customers is really a system that gives you control over how and when you use power. And this is a really profound, to me, profound definition because it captures the intent and the purpose. What is it that the microgrid, what is the system actually doing for this customer? And boiled down to its most simplest form, it's really giving them control. We're operating in a world where things are more out of control than they've ever been for a lot of businesses. Variables and inputs to their operations and their processes are getting less and less in their control over every day, it seems. And so for a lot of folks, what a microgrid is, the proposition, the value add for them is that it's giving control back into their hands. So for customers, I like to use that definition. When you're talking to utilities, they actually often have their own published definitions, depending on kind of the jurisdictions that you're operating in. States often have their own definitions. Local municipalities or HJs also may have their own definitions of what a microgrid is. Engineers might also have a different opinion on what constitutes a microgrid. For some, it might just be the controller itself. For Sunstone, for bankability and for finance, they may have a definition that applies to that case. And then when you're speaking with executives, risk and competitiveness are key to understand when you're communicating these things. So I wanted to sort of set the stage with that, for the purpose of this poll, like all of these answers can be a microgrid in some case, right? It just depends. But who you're talking to is really important, and making sure that everyone's on the same page so that we're speaking the same language is really critical. So with that being said, let me pass the mic to Ruben, and I'll let him take over the content here on the landscape of microgrids.
Thank you, Bo. As Bo stated, my name is Ruben Garola. And so I'm going to talk a little bit about the current landscape of, well, past, present, and future of microgrids. I'm a bit of a history guy myself, so bear with me if in the past, right, of microgrids, I get a little excited for it because I was born back in like 1882 when Thomas Edison literally made one of the first microgrids, right? So microgrids aren't new. It's obviously something that goes back. They were thinking about it even in Thomas Edison's time. His Street station definitely was a microgrid in its sense at the time, being able to serve, over 10,000 lamps. It was DC current running through everything, but it was the first official, you could say, microgrid where it didn't have solar, it doesn't have storage, right? It was just being able to supply this small little district of New York with enough power to power their lamps. We fast forward all the way to several, decades later, where the first cogeneration plant was built, one of the first cogeneration plants. It's usually stated that it's the first one at the University of Michigan. And if you've ever visited this campus, it's actually really cool. Underneath, they have a whole bunch of tunnels where the previous like steam that would come from these 8 boilers would just travel throughout the entire campus and buildings and be able to provide heat for them. But they also had an AC able to, power their lights, power some of the equipment that they had at the time. Fast forward to now, they actually still use the original tunnels. They obviously have updated a lot of the equipment. They're not using, 1914 cogeneration type of equipment any longer. But I mean, it's one of those things where we see now where, presently how far microgrids have come to the point where you think about a microgrid now, you're thinking about backup power, you're thinking about powering all of your lights. Well, this is exactly what it was doing at its time. And this was over 100 years ago. And you fast forward again to World War II. You needed to supply a whole bunch of outposts on islands everywhere. So you have fuel diesel, just from one point to another, creating their own electrical grids, creating their first off-grid, like microgrid. You could say, I've always liked military history. That's one of my things that I personally like. So it's really cool to see from going, from 1882, almost, half a century later, just how far they really have come to being able to supply energy at a district in New York to supplying energy out on an outpost on an island, tens of thousands of miles away. So I'm also semi-hippie at the same time. So maybe here, some people have heard of the Whole Earth Catalog back in, in the 60s, 70s. And you think about it back then, right? Like it really started with people wanting to get off grid. And if you think about it, to get off grid to supply their own marijuana. It's very funny. It's you don't think about it at this time. There's actually a documentary that's coming out later this week or later this year that touches upon that. It's called Solar Roots, and it's just really with some guys that were people that were just really trying to get off grid and trying to grow their own weed. But what sparked that from that was you had a lot of people that garnered this interest to what can we do further? What can we go from 12-volt batteries, 33 watt, 50-watt solar panels to what is the future? So we went from, $29 a watt practically to a solar panel back then to now currently we have what we see 28 cents, sometimes 26, depending upon the current landscape. But yeah, no, that's a little bit about the past. I want to talk about the present and the future as well too, not to get too caught up in the past. But the demand for energy obviously has evolved from Thomas Edison's time, from World War II, even from the 70s and 60s, right? We have large, vast networks of interconnected utilities just nationwide. But what comes with it is the possibility of outages, grid constraints, where, once it was just campuses, hospitals, militaries trying to generate their own power, almost everyone nowadays trying to pay less, create their own energy, and just so they could become less dependent upon these utilities. I know this past weekend, I heard or read an article that lights were flickering in the East Coast because of just the congestion that data centers in Virginia were causing to the electrical grid. So now, even more so, the current factors that are driving these data centers that are just driving more and more construction that we're seeing is the only thing that's going to possibly help this or speed everything along is the development further of microgrids. Whereas microgrids in the past were more of like a disaster insurance. Now grid reliability is just not affected, but by storms, extreme weather, fire risks, and such of that nature. But I mean, businesses are looking more and more at microgrids as just a way to risk of losing the power from the utility and also, result losing revenue when utilities drop. This past weekend, lights flickering, that's enough to scare a business that's operating 24/7. We have worked with businesses here that operate on 24/5 and PG&E or one of the utilities will let them know like, hey, we have to shut you down for today. Well, that's lost revenue for them. Whereas if they had a microgrid and they were able to continue production, who knows, how much more value they would have gained for those days that they were cut off. So that like a lot of the present landscape is just a lot of the bottlenecks. Instead of waiting for utilities to upgrade the grid for the infrastructure, these large, commercial and industrial clients, they're taking things that matters into their own hands by wanting to generate their own power. Instead of having 12-volt batteries, with 33-watt solar modules, we're seeing 720-watt modules coming in on some of our ground mounts that we're installing. You know, some of the larger batteries of 4 megawatts, capacity wise. It's one of those things where at the moment, solar and battery energy storage coming together is allowing more and more customers to take matters into their own hand. And we're not just seeing it on for commercial and industrial. We see it in residential. We see it for utility scale. We're seeing it more and more, just literally for everybody, right? Everybody from California all the way to the East Coast, where it used to be a California thing. It's gone even to the Midwest, where we have states now changing a lot of their policies based upon that. And as I stated with, this past weekend with AI data centers, kind of congesting the electrical grid, we're going to see that more and more in the future. More data centers, more construction, more large businesses, more equipment needing to be needed, right? So with more planning coming online, there's going to be increased bottlenecks in the grid. So it's just one of those aspects where we're getting more and more to where microgrids are becoming ever more important. But, you know, AI data centers also will have a part to play in that because AI-driven controls would be able to analyze real-time, utility rates, weather forecasts, solar productions, and historical load profiles. So the very data centers that are going to need this increased energy will also be able to help us in creating microgrids at the same time by providing better controls that we're able to use on the fly right at the time, and being able to truly get off grid for our customers. The future of microgrids is they can turn into virtual power plants. We're seeing that more and more. We're interconnecting microgrids, export energy back to the main grid. We're seeing more VPPs. The present day, I know some states are including that into some of their that they are also creating right now. But a microgrid is not just your solar and storage. As I stated a second ago, you have your controllers, and more, they're going to become smarter. They're going to become more interconnected, and because of that, it's going to be create as a more highly profitable asset. Your solar and storage is not just creating energy anymore, but it's able to charge and discharge at times when not only you're able to handle the customer's load, but also at the same time, you can get the most money back from your utilities by giving your energy back to them. Hopefully, we start seeing utilities play a little nicer with that, as a lot of them are switching from NEM over to MPT. But hopefully, as technology changes, the policies will help customers as well too. If not, then that's where we step in, and we could definitely help at any point to make a microgrid. But that's just with any solar person, right? But that's my take on the past, present, and future. I believe that's my piece. I will move it on to the next section.
Perfect. Thanks, Ruben. Excellent to hear about the history and present and future. So for this conversation, right, we talked a little bit about how I mentioned that not every microgrid involves renewables, but for as it relates to Sunstone and this webinar, it usually is going to involve renewables in the form of solar and storage, and Andrew's going to share a little bit on everything else. But it's pretty straightforward. I think in terms of this component, I would expect most everyone here is familiar enough with various solar manufacturing options, various battery manufacturing options. So we're not going to get too much into detail with that, but it is a critical component. Obviously, you need to have on-site generation taking place. You need to have, if it's intermittent generation like solar or wind, you need to have some technology available to capture that generation and dispatch it at a time that makes sense for that project. So with that, I'll bring Andrew to share a little bit about some of the more technical elements behind microgrids.
Thanks, Bill. I'm going to pick up right here. Just introduce myself real quick. I am Andrew Lackey with Agilitech. Been working on our electrical engineering team for a little over 12 and a half years now. So a lot of experience in renewable energy and various other industries where electrical engineering might apply. Just going over really quickly what we talked about in depth before. What makes a microgrid? Ultimately, just to summarize it, it's power generation and grid forming capability. Most of the modern installations rely on inverters to align your output to the standardized values that we operate at. And the vast majority of the inverters on the market today are grid following, whereas they just measure the connected utilities and match up the values for their production. But on a microgrid that we're going to see, we're needing to have at least one grid forming inverter. This one will lead the rest as they try to follow along with the appropriate voltage values and frequency and everything. This allows the system to generate output when no utility is available, leading it in islanding scenarios. And that kind of just gives you the control of operating when there is no power. Traditional rotor and stator reciprocating generators that we've seen in the past are naturally grid forming by design, but modern day systems often use inverters, and they give you a little more flexibility and control over your system. Now, let's see here. We have just a few items here of the major hardware that's involved in a microgrid. The microgrid controller, the islanding switchgear, protection and relays, and the metering and sensing. I'm actually going to start power flow here and just go with the islanding switchgear just to give you a quick summary. It's typically, you would see a recloser for an overhead system or a circuit breaker for something that's underground or going through a gear. And it's a way to isolate from the utility. The microgrid system typically needs to be remote operated in one way or another. And when selecting these, there's often, depending on the utilities we're working with, a list of items we have to select from for these. They want to be 100% sure that when they are doing planned maintenance on their infrastructure, that none of these microgrids that are popping up are energizing the line in reverse, causing safety issues. And you don't want to be sending power back in those situations when they're not metering it and paying for it. So it's a benefit for both systems, and it's critical for having a microgrid functioning appropriately. Next in the line of power flow would be like the protection and relays. In a microgrid system, it's a bit different than a traditional electrical system in the fact that we have multiple sources of power. We have multiple devices providing input onto the system. So these devices need to be selected for every source, and they need to be coordinated and just aligned so that they function safely in all power generation scenarios. It's something that takes detailed engineering and a close look at all options for the microgrid, and it can get overlooked if we're just looking at it from a code aspect versus understanding how things are intended to operate. After that, we have, let's see, the microgrid controller. In general, it's the leader of the inverters and the devices there and all the auxiliaries that come together. It can control ramping up and down the inverters to meet demand. It can dictate load shedding when the demand exceeds the production available from your generation. And it manages export control for financial efficiency, kind of what Ruben was going over briefly before. The metering and sensing is the last item on this page, and it involves pieces that are incorporated in every one of the aforementioned items. You have your meters, CTs, sensors. They give the truth in real time. We're measuring to operate our safety devices. We're measuring for historical data to manage and make it more efficient on a microgrid system. And let's see here. We have the data to make sure that everyone's getting paid appropriately. When we're net metering back to the utility or buying reduced power from them, we have the data here to line up with what they're telling us. And yeah, thank you, Bo. Communication. Everything's got to talk in a microgrid system. Networking is critical, even more so than in traditional electrical systems. The experts who are designing these, they have to understand what each device and service can do. And we focus on aligning the hardware, physical connections, and the software protocols while providing experience. We know what plays nice versus what might be work in progress across the different vendors and product. And as in the engineering side of things, understanding what's a work in progress, what's going to be the cost of experimentation on these systems. So when new products come in or different vendors have a different item that might come in at a lower cost, well, if it's not established, we know, hey, it's going to take you a certain amount of time and effort and additional products to make it work. And we can provide the best solution in those type of scenarios, given the experience we have. A lot of the items that need to talk to each other, PV inverters, they're getting smarter and smarter. They're often Ethernet capable, if not something similar, and they talk to the grid and they're able to ramp up and ramp down, controlling output for the microgrid generation. BESS is battery energy storage. Things like state of charge, limits, and health from the battery allows us to make the system safe, shut it down if we need to, and give alarms for maintenance and such. Controlling load sharing, start and stop from the generators, all happens via the controller's communication. Load shedding for when we are exceeding the capable generation from our microgrid is important. If we overload our generation, oftentimes the grid can shut down or go under voltage, causing issues downstream. And we need to talk with the utility relays for not just for safety purposes, but for control purposes as well. And then the telemetry and alarms. This is for getting someone on site before there's a safety issue or before there's a maintenance issue, but as well as sending to the fire department if we have something that can be even worse. The new products out have these capabilities monitoring that we can run these microgrids unmanned and safely. There we go. Now, this is a cool graphic of a controller that we've come up with. It has a lot of the typical hardware you'll see inside a microgrid controller enclosure. A lot of times it's variable depending on your vendor, but this is getting the gist across fairly well. I'm just going to go briefly over the major components here rather than talking line by line on everything. If there's anything in particular you guys have questions about, feel free to ask and I'll address it. But the controller typically contains a PLC or similar processing unit with a dedicated UPS backup power. I know that might sound redundant given the microgrid is in essence backup power a lot of the time. However, we want this controller to be awake before and after all other items so that it can control and tell things when to ramp up and down. In that same vein, they often have a cellular network access so that in the case of a utility power outage, we still have communications. If our customer's network cabinet goes down, the microgrid can come back online on the cellular communication and, re-energize that network cabinet without losing communications itself. They'll also have an operator interface often, and when they're specified and programmed correctly, they can manage everything from islanding, peak shaving, arbitrage, black starts, load shedding, depending on the intelligence level of your system, this thing is the brain for it. And could you go to the next one, Bo? Thank you. And then software. Here we're listing some vendors and functions you might see in a typical microgrid system. Many of these software items are integrated with hardware from some of the vendors we have below. Other ones are installed upon site-specific hardware, and other ones still are cloud-based, accessed via the cellular network or otherwise. And there's often overlap in functionality on our software, or even gaps in the product offerings and services that we can see. It can be difficult to plan for if you're not familiar with what software does what, who provides what services. The scope lines in renewables and microgrids are often blurred. Engineering to close these gaps and determine the best product for each task is critical to ensure success. Now, the software that we often see are the 6 here listing, or I suppose the 5 here listed. Dispatch and control is the software system that decides second by second where the energy goes, whether you're running a microgrid to reduce your utility bill or just for backup power. This is going to tell when to charge the batteries, when to export. And the monitoring and SCADA system gives the users visibility and control over their product. We run event logs and alarms, often on a different level, and access controls is getting more and more important for these systems. As we're connected to the network and we're affecting the grid, there's an expectation of safety and cybersecurity that we need to maintain. And the O&M flows, maintenance discipline that keeps performance from drifting, that's essentially the QA of the product and ensuring that it's working appropriately. Because when we're running different intelligence levels and different levels controlled from device to a higher level, which we'll see on the next slide, we need to have these checks and balances to make sure that we're operating in a way that is in alignment with our customers' needs. And then the caution, this is a powerful caution. The software is the easiest thing to overestimate, and that's very true. The integration between all our devices and making sure that we cover all the bases is one of the biggest hurdles in many microgrid projects.
Perfect. Thanks, Andrew. So yeah, agree with that. The software is the easiest in microgrids to overestimate. What we found in our assessment of the software that's on the market today is that there's quite a broad spectrum of capability in each one. Many vendors and developers producing that software or those controller functions also offer a spectrum internally in their products. So differentiating, categorizing, identifying that is super important. There's everything from manual operations and commands, scheduled and state-based, which are pretty logical, or rule-based. There's feedback, which is what's happening right now. That's when the software is sort of receiving feedback from all of the hardware and communications that are taking place. Optimized and predictive, and finally kind of adaptive or machine learning. And we're starting to see some of the softwares out there produce predictive or adaptive level microgrid controls, but honestly, some of them need to go through probably more rigorous assessment or more rigorous testing before we start to see them get deployed a lot in the field. I think that some of them are starting to showcase kind of pilot projects, and we're starting the true power of these. And this will probably become kind of the mainstay as microgrids get more prevalent within this microgrid system. Types of microgrid product, there's different levels in terms of the way that they're being controlled. So device level versus site or supervisory level, power plant versus, is this a networked type of microgrid, or is this a singular load? Does it need to interact with the utility, or does the utility need to interact with it? In some cases, understanding, assessing, and engineering the various levels of intelligence that. So kind of in summary of that section, what makes a microgrid work well? Scoping upfront. I know there's been a couple of questions around this. Does an interconnection agreement need to be in place for PV in a microgrid? The answer is that if it's connected to the utility in any way, then yes, you're going to need an interconnection agreement. The utility is going to need to know exactly what it is that you're building, what it is that is getting connected to their systems, what is it capable of doing, what is the operational behavior narrative around that system, and how is it going to play with the utility? Is it going to operate safely? And can it shut down or be shut down? Feasibility, before I'm going out to any customer and suggesting that they put a microgrid or buy a microgrid, know first empirically that they actually need a microgrid and that's actually the best application for the challenge that they're up against. If they're just a standard kind of commercial customer that is, maybe has just daylight hours operations, like an office space might, where it's kind of 9 a.m. to 5 p.m., then a microgrid may not be the best fit. Planning, understanding in detail what is the utilities policy? They will be one of the surest fire ways to railroad a microgrid project if you don't understand what their policies are around that, especially around rates and bankability. Obviously, shout out to Sunstone. Early underwriting is the best underwriting. So anytime that we're having conversations with the customer where the project's looking more and more like it's going to need to be a microgrid, you're going to want underwriting to understand that as soon as possible. Be involved to underwrite and make sure that the project is going to be bankable. Case studies for us. When customer first approached us, and just for full transparency, this project's not built yet, but the need of the customer was so, I think, relatable to most of the C&I projects that you're going in terms of microgrids. I wanted to use this as part of the case study businesses run into, and the circuit that they happen to be on with PG&E in the peak summer heat. There's near extended outages where it's interrupting their business. This is a senior daycare facility, so they have a medical clinic on site. They have refrigeration requiring preserving vaccinations or any medicines that might need cold storage. They have a kitchen that also has a walk-in back. When you're dealing with safety and general processes and requirement, being able to provide those services for those senior patients, and when you're experiencing outages that are outside your control, this becomes a major for these folks at this facility. They're sending home like 700 people if they experience an outage. These are not people that can drive themselves. They have to have arranged transportation. When you have an unexpected outage, both logistically and practically, and then as for safety as well. Pretty incredible. They had spec'd for themselves using Tesla Powerwalls, which are single phase units, really not legal to connect to the system because it's 3-phase, and they figured out themselves a package for them that includes the ability to island well over 10 hours, which would get them through any outage pretty much any day of the year, as well as obviously realizing the benefits of having on-site generation where they're going to be saving hundreds of thousands of dollars a year in electricity costs because both their consumption charges from the utility. It was born out of a really serious need for backup power and resiliency that due to the constraints of this is a cool example I think applies to probably a lot of businesses that you guys will be. Grid is an awesome project. This one is cool because it's an open RFP right now. So if any of you have experience in microgrids and you'd like to, it's an open RFP. Again, like Andrew alluded to, it speaks to controls different levels bids for 60 days or so. We did all the engineering on this. I personally helped the developer group that put this project together so again, in the same way that you have differing Bakersfield, and it's really exciting. It's going to be probably or systems. You also need to understand that a real milestone software might have is super critical, and then their rules and policies and planning, these are probably the most important. Generally, you're going to want to do some level of feasibility upfront to help them understand that, to help your team understand that before you make a recommendation along those lines, so that they can. A couple of assess here. Interesting because they approached us with a really common complaint that Californian business, they're losing power from the utilities way more than they ever did in the past. And in this particular case, it's a function of the substation fully overloaded. Like the buildings, businesses, and shops and things that are all turning on at the same time. And this substation was not designed to handle the kind of demand that the circuit is pulling on it. And for that reason, they're experiencing, in the past, they were experiencing minimal, maybe 0 outages a year. Now they're starting to experience 5, 6, 7, 8. There are state policies that usually dictate, so major problem. They approached us looking for a solution. It was actually, we're trying to just so we've put together for extended periods of time, and the system is sized perfectly to be able to offset. So it's a multifaceted solution, but they had not planned for it. They had not expected it. This wasn't part of their forecast as a business, but it's now become a critical issue. So in the future, they're taking, for California state universities across the whole state, because of its capabilities is rather unique. So in the past, pilot projects have been completed, state campuses in California, but this one will probably be the most comprehensive in terms of its scope. So Campus scale load, it's going to be offsetting most of the load during daylight hours, and then the batteries are going to be able to carry the load significantly through the evening. It's island capable, so if the utility has to cut off service for any reason, this system will be able to support the campus for the duration, for most of the duration of the outages, assuming it's not some catastrophic outage. But there's going to be a massive amount of coordination. The campus has tons of load all over. They have their own distribution network on site that carries 12,000 volts to most of the buildings around. And there's an extensive amount of coordination required that's gone into the planning and the engineering. Andrew's been heavily involved in this project too. So yeah, it's going to be a pretty interesting project, and the controls and the microgrid software itself is going to be one of the most key components to that. Lastly, for the case studies, this is a example. I don't know, Andrew, did you want to share about this one? I think you were involved with it, right?
Absolutely. Thanks, Bo. Yeah, we did this one a few years back for CRC, which is a local oil and gas producer. They had a remote facility off-grid running on 2 gas-powered generators, and we helped them when their load exceeded what these generators could produce. We helped them to install additional generation capabilities to meet that load. In this case, it was 200 kilowatt microturbine generators using natural gas produced on site. So they had the resource available. They just needed to turn it into usable power. We were able to find a solution coordinated for them so that they can keep up with their growing demand out there on site. And these were different manufacturers and different types of generation. So it was a little complex coordinating which ones will run, which ones will idle, getting them to meet the load and stay there for facility operations. However, it worked for a few years, and then when they had utility power available, we actually got a call back, and we were able to, I think, replace the larger generators with utility-fed transformers, coordinating with the newer microturbine generators for peak shaving and to reduce their bill, essentially. And yeah, I think they still actually have one running today. This site has been kind of an adventure as the utility expands. Sometimes projects just can't wait for the utility infrastructure to get there. So they created a microgrid that was islanding with the capability to integrate with the grid in the future.
Perfect. So there's a question about microgrid controller eligibility for ITCs. That's going to be a question for the tax professionals, which I am not, but yeah, by and large, to that point, the setting the expectations with the customer early on in the conversation is really critical. So for us, my answer to ITC eligibility would be it probably could be, but you're going to want confirmation from a CPA or a tax firm that can that is competent and proficient in ITCs to be able to speak to that more precisely. My general answer to customers would be we have partners, we have firms that we work with on those matters, and they can certainly answer that for you in more detail. Other things that can go wrong, islanding versus not islanding. Microgrids don't, in my opinion, and I could be the outlier on this, but in my opinion, a microgrid doesn't necessarily need to island. The technical definition states that it does, but for the purpose of what can go wrong or right, let the customer know. They need to understand this can island if there's an outage, or it cannot. Wrongsizing, same exact thing. They need to understand what this is intended to do. Is this a 2-hour response system? Is this an indefinite off-grid type of system that can support them whether the grid is there or not ever? Those are all things that you want to address head on. For commissioning, testing is super important. The utilities are going to have a very vested interest in any testing and commissioning process that goes on. They're going to have their own set of tests and inspections that need to get done before you ever get PTO. And yeah, that's kind of the general gist of the things that can go wrong. So in sum, I would say that grading the project from the very start to the point of commissioning, you never can over discuss this with customers, with your engineers, with all of the stakeholders. It's usually a good idea to have multiple parties, multiple expert teams involved, whether it's controls and protection or utility review, obviously financing with Sunstone. Oh, and who's going to be making sure this thing runs? What are the policies and procedures for maintaining this system through its full life cycle? So yeah, that covers, I think, most of the gist of it. So I think
Yeah.
we've got a little time for Q&A.
Yeah, just to kind of add on to what you were saying, Bo, early underwriting is the best underwriting. And I would say that I think how a customer plans to pay for a project should be at the very beginning of any conversation. So I think that would also be the best time when financing is offered as well.
Yep. I think if anyone hasn't answered the poll yet, we can close it. It looks pretty spread, pretty even, surprisingly. A lot of different, like I said, a lot of different shapes and forms that microgrids can take in terms of their configuration, the components and systems that are involved with that. So we've got a microgrid planner. Just wanted to offer something to the folks that attended today, that if you'd like to download a really simple checklist that kind of helps teams, if you've got sales teams that want to explore that avenue with your customers, it could be a helpful kind of checklist just to make sure that they're asking the right questions, that they're exploring the right angles in order to understand whether a microgrid is applicable to a particular project. And these are basically the same processes, same workflows that we go through at Agilitech in order to determine, the feasibility and the viability of a microgrid. So feel free to scan that QR code, download the planner if that's helpful. Also, Agilitech's here to help if you ever need insight or an opinion. I'm happy to jump on a call with anyone to get some perspective from Agilitech on that. But yeah, other than that, I think that mostly concludes our session.
Yep. Thanks, Bo. I will be sending a follow-up email later today with a recording of this webinar, and I'll also have the Agilitech team CC'd in case you guys want to reach out to them for further questions. Other than that, thank you all so much for joining.
Thanks, Lulu, for having us. We appreciate it.
Yep.
Always
Thanks,
good.
everyone. Have a great day.
Bye-bye.